Next up, we've got a circle theorem question. It's not the most difficult in the world. It's nice that it involves tangents because that gives me the opportunity for two very basic facts. So, PQ and PR, so PQ and PR, are tangents to a circle with a centre of 0. Now, something you need to know about tangents, they both come from this point P. And tangents, when they come from an external point, so they've both come from the same point, wherever they meet that circle, they are of equal length. Alright, so those two lines are equal. That means, if I use my little name badge again, cover the rest of it up, forget about any circle involved. That means I've got an isosceles triangle here. Alright, so two equal lengths, but also, if I mark on in green, two equal angles, because that's an isosceles triangle. However, I'll come back to that in a second. So, they are tangents to a circle. I know that they are equal. Find the size of OQR. It's got the lid above the Q, so that's an angle. So O to Q to R. That is the angle that they want me to find. You must indicate any angles that you calculate. You must give reasons for each stage of your working out, and it's worth 5 marks. Now, it's worth 5 marks, but there's only really 2 pieces of information that you need to know here. Alright, so, as I mentioned when I read the question originally, I saw tangents and I talked about the length of the tangents from a point on the outside of a circle. However, another rule about tangents is that tangents always make a 90-degree angle with the radius of a circle. So, whenever I see a tangent, I'm going to ask myself, is there a radius anywhere around? And please don't be tricked into thinking, oh yeah, there's a radius, so that's 90 degrees. It's not. You go to the centre to find the radius. So the radius is here, from the centre to where the tangent meets. And that there is a 90-degree angle. Okay? So the very first thing I'm going to write is, and I'll do it for this one up here, well, I'll do it for both of them, is that angle PRO, so PRO with the lid above the R. So angle PRO is equal to 90 degrees. I didn't calculate that. I'm just going to write my reason. So PRO equals 90 degrees. And I'm going to write that tangent meets radius at 90 degrees. That's the rule. You might choose to use the word perpendicular in place of 90 degrees because a 90-degree angle is perpendicular. It's when two lines do that. But make sure you're not using the word perpendicular if you don't know what it means. Okay? Tangent meets a radius at 90 degrees. Now, because PRO equals 90 degrees, and these are radius, these radii are the same, and the tangents are the same, that means the angle PRO and PQO are also the same. Let me pick a colour pen to do it. So that is saying that this tangent meets this radius also at 90 degrees. Now, ultimately, I want to find this red part, which the question is asking for. But in order to find that, I need to know the green part first, because I know that together the green part and the red part are going to equal 90 degrees. So let's work on finding one of those green parts. So I'm going to make the statement here as well that, before I move on, sorry, P, Q, O, so P to Q to O, with the angle at Q, is also equal to 90 degrees. For the same reason, okay? They're equal. Alright, so to find the green part, I'm going to focus on the isosceles triangle that I've got here. So angle P to Q to R, P, Q, R, with the angle at Q. In order to find that, I'm going to recognise that ultimately it is a triangle and it's an isosceles triangle. So there's 180 degrees inside this triangle. They've given me this 30, so I'll take away 30. That leaves me with 150 degrees. And with that 150 degrees, I need to realise that it's got to be split between that angle and that angle, which are equal. So 150 degrees split between those two angles equal 75 degrees. So each of these green angles are 75 degrees. Now finally I can calculate angle RQO. So angle RQO, and I can calculate that because I know that the whole thing is 90 degrees. This part is 75, and therefore that part has to be 90 degrees. Take away the 75 degrees equals 15 degrees. Alright, now I missed out a reason up here because this 180 had to come from somewhere. So the reason you need to put here has to be along the lines of an isosceles triangle has two equal angles. You could also provide a reason that it's isosceles, and you know it's isosceles because tangents are equal from an external point. Right, you could go to town on all the reasons, but eventually you get the angle as 15 degrees. The more information you put, the more chance you have of getting the marks.